Hello everybody in the Programming Language Concepts course. This lecture covers chapter number 8, and it is from lecture that is titled chapters 6, 7, and 8. So chapter -6, -7, -8, I'm hovering my mouse over it right now, is the name of the lecture. The lecture is in the lecture folders, and this is chapter 8. Chapter 8 will be the last chapter that we will cover in this class. So this is the kind of the last instructional type of video. I will have some information about the final exam coming to you shortly. I will also create a video about which chapters to read or which sections to read in the book. But this one's going to cover chapter 8. So we're looking at compound statements, selection statements, iteration statements, and unconditional branching, and then guarded commands. This is pretty easy stuff if you've done any programming before. The chapter gets into the concepts of the levels of control flow. So the flow control, or levels of control flow, we're talking about flow control or control flow. You could say flow of control, or you can say control flow. They both mean the same thing. It's the execution sequence. What order are the commands executing in? In some programming languages, that order is definitely stated by the programmer, and those would be imperative style languages. In other languages like Scheme, the programmer does not program flow control. And the only thing that's available in the language is the concept of recursion. So programs run in Scheme, they run by running functions, and those functions run themselves, and they run recursively. And so the recursion is the flow control, but there's no control over it. It's controlled by the compiler. So when it comes to different levels of flow control, we have different levels that can be from within expressions, among program units, or among program statements. So within expressions, this would be sort of like saying that in a comparison, if X is larger than 5 but smaller than 50 and not equal to 25, then do something. That's an expression that provides a level of flow control, and the level is determined, or the flow control is being determined by a statement, or an expression. And then among program units, a program unit might be a subprogram, like a function, and within the function there's a particular control going on, and you're controlling how the function is operating. And then within among program statements, this would be if I was running main and I was running making instances of objects, or if I was running functions or doing whatever, that would be in the program level statements versus among program units or among program subunits. So statements that provide the capabilities such as selecting among alternative control paths, or causing and repeated execution, or certain collection of statements that are called control statements. So if you have a bunch of control statements encapsulated together, you can call them a loop, or you can call them a case switch, or an if then else. We have different types of loops. We have different types of multiple selection and single selection types of control statements. These are all really classified as what they call a control structure. So a control structure is a control statement, and the statements whose execution is controlled, that it controls. Well, a control structure is called case switch. Case switch, if then else, do while, for each. Those are called control structures, and they are providing levels of a control flow or flow control. All right, I'm not going to go through the history of all this, but it came from Fortran. And the go-to is the first control flow statement. We don't have, actually go-to still work in some languages. We don't use go-to. Go-to creates spaghetti code. It's pretty hard to look at. And so we had cleaner looking ones, and Algor begin end, which Pascal took over. So Pascal started with the begin end, and they created these blocks. And you know what a block is. A block is from an opening curly bracket to a closing curly bracket. It's the scope in which the flow control is visible. So a block is a compound statement that can be defined by defining a new scope within local variables. So some design considerations, overall design questions you have to ask is what control statements should a language have? You're going to create a language. What control statements are you going to put into it beyond the selection and the pretest logical loops? I'm going to get into those in a few minutes so you know what those are. And whether or not the control structures, could they have multiple entries? Can they have multiple exits? How are we going to control those structures? So let's take a look at the selection and the pretest logical loops. So selection. So here's some classical classifications of control statements. A selection statement. So a selection statement, you choose between two or more execution paths in a program. That's the if, else, then. And it's the if, then, else is a two-way selection statement. You could have if, else, if, else, if, else, if, else, if, and then you could have I don't know how many else ifs I just said, but that would be 3 or 4 or 5 different ways, different paths. So the ways of exiting are the paths that can be taken to exit out of the structure. So you select one of two paths in a two-way if you have if, then, else, and you don't have an else if, an else if, an else if in there, then you can have more. So design issues. Now remember, these are not issues, they're not bad things, they are considerations, things you need to think about if you're going to implement the concept of a control statement. What's the form and the type of the expression that controls the selection? In C, C++, and in Java, to answer the question with an example from a language, this would be a Boolean expression. So anything that equates to true or false, or the word true or false actually works. Boolean variables can be used as the expression that controls the selection. When it comes to the case switch, it's an integer or a character in some languages. Some languages don't have a limit on what the control statement can be. But yeah, usually most languages today, modern ones, are using Booleans, but that's a consideration. Are you going to use a Boolean? Anything that comes back to true. Can a single statement, a sequence of statements, or compound statements be selected? Most languages give you the choice of all of them. If you don't use curly brackets, then only one line gets selected. If you put the curly brackets in, then multiple sequences of statements can be selected. In fact, you can even leave. You can have compound statements as well by going to calling another function from within it or something of that nature. So there's no limit in most modern day languages, but that is a consideration that you need to think about if you're going to implement the concept of control structures. And how should the meaning of nested selectors be specified? So if we have nested selectors, those would be ones inside, like else if is a nested selector. So if, and then some languages actually have an end if, or they have an else, or they have an else, or they have a then. That's what these are talking about. These are nested selectors. Should we have an else if, an L if, like we have in Python? Should they be other default? How should we specify the selectors that are nested inside of the control structure? Here is a nested selector. Consider the Java language. Java has just else. Actually, I thought there was an else if in there, but these are nested ones. And so now we have nested if inside of ifs in Java as well. C++ supports the same thing as well. So if, we just keep going in. In Java, as in many other imperative languages, the semantics language specify that the else clause is always paired with the most recent unpaired then clause. Well, we don't have a then, so if we had a then, it would be right here. So if this, then, so this slide is basically telling you that there's an automatic pairing with the else's, and that's how the nested selectors are being created. In Algor 60, it's done using syntax. If the S is nested inside of the then, it must be placed in a compound statement. So some languages have restrictions, and you don't need to know how every language implements everything. It's just showing you an example and a definition of nesting selectors. Here's that begin end. I kind of like the begin and in the end. This actually is an Algor example, but it was also in Pascal. So begin, end, and then you've got if and else inside of it. So there's many different ways. And Ada uses this kind of sort of pattern as well. So Ada is a language you might run into if you ever work for the government. So an alternative to it requires a special closing words, then and else. I don't see the end if in here. I see end. I think it was Visual Basic actually that has end if on it. So they come in different forms. And then we have the multiple selection constructs. Well, this is the case switch. So in most languages, they group the switch construct together. It originally came from Fortran. It is it's in Java and C and C++. And so the switch is going to switch between different cases and some design considerations. And this is a multiple way selection. They call it a multiple, not a single, or it's a multiple way selection, which means you can have multiple outs. To test this, create, and maybe we'll show you the case switch here first. The Pascal. Okay, here's one up here. I'll go back to that slide in a few minutes. Switch an expression. So switch X, and then we have we have the expression number 1, expression number 2, expression number 3. Is it X a 1? Is X 2? Is X 3? And then we have default. So if you don't put a break in here in between, multiples will select. You can try it out at home, or if you haven't worked with case switch in a while. Leave out the breaks and see what happens. You're going to get multiple selections. So the first one that's true executes, and then everything past that will execute. That's what they call a multiple way selection. We turn it into a single way selection when you put the word break in between each one of the cases. So after each, if case number 1, break, case number 2, break, case number 3, break, and then you've turned the multiple into a single. Okay, so some design considerations for the concept of a switch case, which is a multiple way selector. What is the type and form of expression that controls the selection? Is it a single value? Is it a Boolean? What is it? Usually it's limited in C, C++, Java. It could be a character. It could be an integer. It can't be a float. It can't be a double. There's some limitations on what X is in that example I told you. May single statements, sequence of statements, or compound statements be selected? Usually the structure is left wide open, and you have to put the break in on purpose because we want to make sure that we're allowing for all of these different conditions. So a single statement could execute, a sequence of statements could execute, or compound statements could execute. And just in case you're not clear between the difference between sequence of statements or compound statements, sequences of statements would be more than one, like, do this, do this, do this, do this. Compound statements, that means you're calling a function or you're calling another grouping of statements that are going to run together. They're all compounded and encapsulated together in the form of a function or a loop or something. They're compounded. Very similar to a sequence of statements because compound statements generally include a sequence of statements. So, is the entire construct encapsulated in a syntactic structure? Like switch is an example of that, actually. The encapsulation of this is a switch. I call it a case switch. It's really a switch case because you switch, and that's the outer compounded structure, and inside you have case 1, case 2, case 3. So it is in C, C++, and Java. It typically is a compounded syntactic structure, this bullet point here. Is the execution flow through the structure restricted to include just one selectable statement or segment? In most languages, it is just one. We're switching X. We're not switching X, Y, and Z. Some languages, actually, you can switch multiple variables or multiple selections, selectable segments. But you are probably only familiar, because that would be a Pascal kind of thing. You are probably only familiar with a single. It was reduced down to a single one in C, as well as C++ and Java. And Java pretty much covers C++. It does the same format. How should unrepresented selector expression values be handled, if at all? That would be like the default. What if none of those cases are true? Then should we have a default? And I think I have an example of that coming up. So Fortran had the arithmetic if, was a bad aspect, so it was not encapsulated. Segments required go-tos. Fortran computed the go-to and assigned a go-to for everything. That was not good. Pascal came up with the case. They were the first language who used the case. In the case, some design choices. The expression is any ordinal type, an int, a boolean, a character, or a numeration, instead of just an int or a character. So originally in Pascal, you could use different selector types, expressions. Segments, they could be single or compound. You had the ability to turn it on and turn it off, kind of like how the breaks were incorporated in C and C++. The construct was encapsulated. In fact, it's encapsulated the same way, except there's no switch word. C++ added the switch, which kind of made it a little bit easier to read. Only one selection can be executed per execution of the construct. It didn't allow multiples. It wasn't freed up like C and C++, where multiple of the cases could execute. Only one of them could. The result of an unrepresented control structure value is undefined. It didn't have that in there. It was just undefined. So many other dialects here, they have otherwise or else clauses. The Python, you can actually put an else in the case switch. So here's our C one I showed you a few minutes ago. The design choices for the switch, the control expression can only be an integer type. I don't know if that's really true. I think you can put a character in there. I'm vaguely remembering a character in there as well. But I know it's restricted. It's definitely an integer type. You might, certain dialects of C or C++, especially, maybe it's Java, actually, I'm thinking of, that can use a character. Selectable statements can be statements, sequence of statements, blocks, or compound statements. So that's why you have to put the break in there. Any number of segments can be executed in one execution of the construct. There's no implicit branch at the end of the selectable statement, so that's why they all go. So if you leave out the breaks, every single one of the cases will execute until the construct is finished. And then we have the word default. If you remember default, this is not the proper syntax, it's just pseudocode. You put default in there, and that gets the unrepresented values. If there's no default, the whole statement does nothing. It does not come back undefined. It just comes and doesn't do anything at all. So, just in case you haven't seen one in decades, here's the switch month. Month is a integer, and we have a break. And we have a default down here with no break, and then we're going to return the days at the end of this program here. So this is a pretty easy example. So hopefully you remember how to use those. So, and we have multiple cases, case 4, 6, 9, and 11. So I can put them together if you'd like as well. And then along came iterative statements. These are loops, iteration. That's why I say this chapter is pretty easy because you've all programmed before. The repeated execution of statements or compound statements is accomplished either by iteration, recursion. So iteration and recursion. We know that recursion can be used in place of iteration in some imperative languages. We'll look at iteration because recursion is unit level control and not statement level. So unit level. So it's generally how a language is designed to run, like a functional programming language. General design issues for iteration and control statements. How is the iteration controlled? Do we control it at the beginning of the construct, at the end, in the middle? And what's the control mechanism? Is it a variable? Is it a Boolean expression? How are we going to control the looping? So the primary possibilities for iteration control are logical, counting, or combination of the two. Top or down, the bottom or on top. We have post-test, and pretest. We're going to protest the loop. But the post-test and the pretest are the two that we're familiar with the do and the while. So let's get into some examples. Most people can probably iterate through and kind of speak out a counter-controlled loop, especially if you've created it multiple times in a language like C or C++ or Java. A counter-controlled loop is a loop that has a counter, and the counter is generally in the loop construct. And so some design considerations, and let me just give you an example one here. In the C language, the most common, the most famous counter-controlled loop is the for loop. For I is equal to 0, I is less than 10, I plus plus. That's a counter-controlled loop. It's in most 99.9% of all your languages. We can rely on that loop being part of the language. So what is the type and the scope of the loop variable? I, is it defined before? Is it defined after? Believe it or not, there is a change between C and C++ when it comes to that, and I'll get into that momentarily, but that is a design consideration. What are you going to do for the loop variable? And what is the value of the loop variable at the end of the loop? After the loop terminates, does the value get set back to 0? Is it still in scope? Does it go away? Should it be legal for the loop variable or the loop parameters to be changed in the body of the loop? And if so, does the change affect the loop control? So if I had that, if I was equal to 0, I is less than 10, I plus plus, and then the first line of my loop says I is equal to 10, am I going to allow that? It actually is allowed in C or C++ and Java. It is not allowed in other languages. Should the loop parameters be evaluated only once or once for each iteration? Well, I is equal to 1, integer I is equal to 0 is only evaluated one time. And in that particular example, the second two statements, I is less than 10, I plus plus, is evaluated each time the loop is iterated. So there's the syntax of that C loop I was talking about for expression. This is the I is equal to 1, I is less than 10, I plus plus. The expressions can be whole statements or statement sequences with the statements. If the second expression is absent, is an infinite loop. Yeah, you could just go integer I is equal to 0, I plus plus, and then you have a loop that doesn't end. Usually people would use a do or a while if they had that, but you can create an infinite loop with a counter-controlled. So the C choices, the design choices in the language of C, there is no explicit loop variable. You have to come up with your own. Who came up with I? It's just, some people use C for counter. I like to use I, but people use C. So and these 1 through 5 are answering these 1 through 4 questions, and the fifth is kind of an add-on there. But there's no explicit loop variable, and so number 2 says irrelevant. Well, irrelevant means that what is the value of the loop variable at the loop termination? It's irrelevant because C has local scope, and that variable is gone. We don't know. It was just a temporary throw it in the loop, and then when we're done with the loop, there's no value to it. It's not 10. It's not how the loop stopped. It didn't get reset to 0. It just doesn't exist anymore. Everything can be changed in the loop. That's answering this question here. Should it be legal for the loop variable or the loop parameters to be changed in the loop body? And if so, is that going to change the loop control? Yeah, it can. Everything can be changed in the loop. And then number 4 says pretest, which is the 4 here. Should the loop parameters be evaluated only once or over multiple times? Well, this is number 5 actually. The first expression is evaluated one time, but the other 2 are evaluated with each iteration. So the one that's kind of off sync with the previous questions here is number 4, which says there's a pretest. So this type of loop does do a pretest, and the pretest, and this is really getting into this kind of concept of there being a pretest down here. Are we going to check the control before we run it or after we run it? So pre would be before, which we do. In our counter-controlled example, we say for, and that's the first expression. I is equal to 0. Okay, test it. I is less than 10. That's a pretest. If we had a while loop, and at the end when we did a do, and at the end we executed one time, and at the end it said while x is less than 10, that's a post test. This loop is the most flexible, which is why it is in most languages. It's in most languages control it just like C. So you learn it in C, which makes C a good language to learn as a first language, because then you can apply it to other languages, because a lot of the control mechanisms are the same. So C++ differs from C. Most people think the loop is actually the same, but it does differ. It differs in these two ways. The control expression can also be a Boolean. I think you can throw character in there too. Originally, it was designed to be an int. C++ and Java, I think, support a character. I could be totally wrong on that. I know they support a Boolean and an int. The initial expression can include a variable definitions. So you can say integer I. In C, you were only able to say I is equal to 0. You had to define and declare I outside of the loop. In Java and C++, you can actually declare the variable inside of the loop, and it's a new I, and you can just repeat it over and over again. So the scope is from the definition to the end of the function in which it is defined. So I, and this is the function of the particular control structure, not a function in this particular statement. So if I did integer I is equal to 0, I is missing. I can't reuse I if it's inside of that control structure. If I went integer I and then in the control structure said I is equal to 0, then I can reuse I, but I doesn't have a value to it yet. It's unassigned. Java differs from C++ in two different ways. The controls expression must be a Boolean, so it has to go to true or false. And then the scope of the variables defined in the initial expression is only in the loop body. So when you end, I is gone, and the expression itself is gone completely. For the most part, most people don't. I mean, they think it's the same, but there are some differences. And you don't have to know the differences for the final exam. You just want to know what a logically controlled loop is. Excuse me, a counter-controlled loop. So those were the counter-controlled loop. For is an example, the for loop. You also have the for each. You have different variations of the for loop, not to let you know, not to give you the impression that this is the only counter-controlled loop that exists. This is an example of one. In other languages, you have for each. You have different variations, but it's the for loop in general. The logically controlled loops are the do while. They come in two sets. You've got the do, or you get the while. You also have repeat until, two different words used for the same thing. So some design considerations. Are you going to allow a pretest or a post-test or both? The C language actually provides for both. You can test before you run the loop, or you can test after. Should this be a special case of the counter-controlled loop or a separate construct? And you can create a for without a condition to make it a logical loop, and inside of the loop change the value. You can make a for act like a do while. This is why some students, when learning programming, they question at the end of their first programming class, when do you use a do while? When do you use a for loop? Why should I use an if, else, then? Or should I use a case switch? When am I supposed to use these things? You use them as like tools in your toolbox. They're statement level control structures to manipulate the lines of execution, and they come in handy when the programmer wants to use them, and there's no limits. You just use the constructs with the requirements of the characteristics or features that they contain. So here's some language examples. Pascal had the same thing, had the pretest and the posttest, but they did a repeat and repeat until. So the syntax was a little bit different. C++ actually copied Pascal but made it simpler. The control statement is treated just like the pretest, so we have the while do and the do while. Java's like C, except the control statement must be a Boolean. It must evaluate to true or false. And the body can only be entered in at the beginning. You can't get into the loop in the middle of it. So let's take a look at some examples here. These are the Ada / Pascal looking ones. So some design issues or considerations to think about with the for and the loop. Should the control be part of the exit? Should the mechanism be allowed in an already controlled loop? And should the control be transferable out of more than one loop? These are all answered yes. You can do all of this stuff in most modern languages. It was limited, though, back in the Ada days in the beginning. So this might be a little bit more relevant to you. And again, you don't have to know how each language implements the for loop. You want to know, the logical controlled loop. You want to know the concept of the logical controlled loop. In C, C++, and Java, there was a break in there. You put the unconditional for any loop or switch. One level only. Java can have a label. You can put labels in Java, actually. I'm not going to talk about labels because they're sort of like go-to statements. There's also a continue statement for loops. It skips the remainder of the iteration, but does not exit the loop. It just goes back to the top of the loop. Let's skip the Fortran examples because you're probably never going to program in Fortran. But yeah, you can put a break in there. You can put a continue in a loop in the C, C++, and Java, which pretty much are all the same. Modern C++ requires a Boolean as well. So iteration may also be based on data structures. So Python has the for each. Perl has the for each. So it's called an iterator. Java actually has a built-in iterator in the Java utils, not part of the base core, but it's a util library that a lot of people use, and it does have the for each, and it has the next, the next, the next. So this concept is to use the order and the number of the elements of some data structure to control the iteration. So instead of using a loop that you're creating, you're using the data to control the data. So the control mechanism is called to a function that returns the next element in some chosen order, if there is one, else it exits. So we have C and we have Python, we have Perl up here. Let me give you a Python one, which is very similar to the Perl. You can say for X, and then have some lines of code, and then go next, 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 and get each one of the lines. Or for each I in, there's a for in, for I in this list, or for X in this tuple or something. So those are iteration based on data structures. So it's the data structure itself using an iterator that goes through it. Hopefully they gave you some iterator information in your data structures and algorithms course. But it's pretty simple in terms of understanding the data structure components. And it depends on which data structure you're using in terms of what iteration might be available. If you have a stack, it's going to be a push or a pop. So and maybe this might help you understand it. A stack, the iteration is based on inserting and removing through commands called push and pop. The push and the pop, those are iterator-based mechanisms. An enqueue, a dequeue for a queue, an add to list, add to top, add to bottom. Those are iteration based on data structures. So you can see the chapter is fairly straightforward if you've done any programming before. The information will make a lot of sense to you. You don't have to worry about guarded commands or anything. And I'll go through the chapter for you in another video to tell you what to look at in terms of the chapter content. But yeah, don't worry about guarded commands. Those are not part of the testable material. So that concludes my lecture on chapter 8. Pretty lightweight. Go ahead and read through the chapter, but stop at guarded commands. And stay tuned, I will give you another video on the reading that you should do for the final exam. So I hope you've enjoyed the video, and I will talk to you again in another video. Thanks for watching.